Guys, have you ever wondered how JavaScript engines store objects like this behind the scenes in the browser or JavaScript engine memory? Well, you have come to the right place if you want to know what data structure JavaScript engines use behind the scenes to store objects and big arrays in your application behind the scenes. Now, let's take an example. I do have this object obj and it has only two properties. Now, what do you think? What type of data structure should JavaScript use to store this small object which has only two properties? Well, if you are thinking like object should be its own data structure, well, it is on surface level, but behind the scenes, it uses some different data structure we are going to talk about in a bit. But for now, let's take an example. If you have an object with small properties like 1 to 10 properties, then it's going to use a data structure which is called array. I know you guys have been working with arrays since long time if you are learning JavaScript or if you are a working professional. But I guess you never know like your object is also being stored in an array behind the scenes. Well, it is true. Your JavaScript engines like V8, if you have an object which has around 1 to 10 properties, it is going to be stored as an array behind the scenes. But how it's going to work? Because array is something like it has indices and the actual value, right? How it's going to store this object there? So JavaScript engines are very advanced. What they do is they attach one extra shape in your objects, or I would say extra shape with the array that is called hidden class. Now what's going to happen? If you see this object behind the scenes, what JavaScript engine is going to do is it's going to create two things. One is hidden class and one is backstore. Backstore is going to be an actual array. It is going to be an array. Hidden class. Well, it's an interesting topic. Hidden class is nothing, it's a shape. It's just like it's a shape which helps your JavaScript engines to know which property is being accessed from an object. Or what type, if you are having an object or a class which has a very difficult or I would say like complex shape, it's going to create hidden class behind the scenes so that you can easily traverse all the properties on the go. You don't need to wait. JavaScript engine already know what this object contains, what are the properties present in this object. So it's going to be like this. It's going to do what? It's going to map, like there are two properties A and B. So it's going to map A with index 0 of backstore. Now in the index 0, the actual value is going to be 1, this one. And it's going to also maps B, the property name, to index 1, which is going to be 2. So behind the scenes, if you're creating an object which has less than 10 properties, I would say there's no such threshold. If a JavaScript engine see like this object is very simple and all the properties are very simple, there are no dynamic property, there is no very I would say difficult shapes, difficult structure assigned to the values of this object, it is going to use an array. Array going to have two things, hidden class, which going to map the values or map the properties with the index of the backstore, and the backstore is going to be an actual array. Why it does do this? Why your JavaScript engines create an array behind the scenes rather using some other complex data structure? Well, it's very simple. Array are very simple. They are sequential data. And as we see this object having only two property, they are sequential data. There is no complex property assigned to this object value. So it's just going to create a array, which makes sense, right? There is no complex things here, just like A to 1, B to 2, and they can easily map with this hidden class structure. This is very important. Before 10 properties, 1 to 10, it's going to have an array. But if you have a property more than 10, I would say 30, 100, 200 with some complex data. Now here we do have two things. One is array and one is an object. This array has some properties on an index 1 with value 100 and on index 1000 with value 200. So it's in sparse array. There are so many indices here which are empty, right? Here, I do have an object which has around 999 properties. If you see 1, 2, and each property is going to have the same value, which makes sense. But this object has lot of properties, right? And it's going to be 1000 actually, from starting from 0 to 999. Now what's going to happen? If a JavaScript engine sees a very complex object, a very big array, it's going to use another data structure behind the scenes, which is known as hash table. Hash table is a very most used data structure, I would say, in real world programming. Even I use maps, which is similar to hash table in JavaScript, to solve some complex problems, I would say, or store some data which I want to reuse them later. Hash table, hash map, nothing, just a combination of key and value. Key and value. Just like a map you use in JavaScript, we have used, or in any other programming languages, you may be using maps. It is very simple. Hash table, key, and value. Why does JavaScript engines create hash table behind the scenes for large objects and large array? Why? First thing, when your object or an array becomes unpredictable, object or array becomes unpredictable. See, when we are creating simple object with only 2 or 10 properties, then it is predictable. There were no complex value assigned to your object. The JavaScript can simply manage those type of data structure using array, with maybe having hidden classes to have the index value mapped to the values. And is how your array becomes unpredictable as per JavaScript engine. Let's take an example. If you do have an array of 1000 elements, it has lot of elements, I would say. If we talk about the time complexity of operation performed on an array in JavaScript, I would say first add. If you're going to add the element at the last position, it's going to be big O one. It just needs to go to the last position and it there. And in the worst case, if you want to add the element at the first position, then it's going to be like, and it needs to shift all the elements to the right side one place, right? And the delete. Okay, if you're deleting an element maybe at the last place, or if you're deleting the element anywhere in your array, it's going to be 1. But it's going to left that place empty with undefined, right? It is going to be undefined if you delete something. And in the worst case, like if you want to shift elements, it's going to be big O1, as simple. And it's going to be read as well. Read is going to take big O of 1. It's a simple operation. Is going to read the, whatever index you pass is going to read the value from there. This is a problem. Sometimes it takes a lot of time there in some operations. But now if we compare it with the hash table, if you have the hash table with keys 1, 3, 5, 1000, 100 maybe, values, whatever value you have. Now in case of hash map, the worst case of addition, or I would say the time complexity of addition is going to be 1. In the worst case, it could go up to n. When we perform rehashing, we will understand a bit. This only happens when we are using in dictionary mode. Dictionary. Oopsie. I guess I need to switch it there. And let's remove this and let's mention it there. Dictionary mode. This only happen when we use Hashtable as dictionary mode. There are two mode JavaScript engines does use. One is fast mode and one is dictionary mode. Let me write the modes. Fast mode, dictionary mode. Okay, so this is also something very important. Like if you are having the maintainable, or I would say like at some threshold properties, like not very very big, like uh, thousands of properties, maybe in hundreds, and it does use the fast mode hash table. And if you go more complex in data structure, then it's going to use dictionary mode. All right, this happens very less. Big O and other, most of the time it does use the logo one. Same for the delete, big O one. In dictionary mode, it could go worse up to log n. Read. Read is going to be big log O1. Alright. Hash table has more advantage over array. Array is a linear data structure, and hash table is some kind of a table which is very easy to look up. Most of the time when we are using, when we want to store data and want to perform lookups, read and write in very fast manner, most of the time we do go with hash tables or hash maps. Now let's understand some non-thresholds when your JavaScript engines convert their objects or an array to a hash map or hash table. I would say hash table. Let me write in green when. Alright. The first thing is adding dynamic keys. If you are having an object like this and you add dynamic keys, like see, if you see it here, I'm adding a dynamic key with this arrow say, in the square bracket syntax. That is going to convert it to a hash map, because when you add dynamic keys, it is not going to be a linear data structure at the time we create an object like this. It is no more going to be a linear data structure. It's going to be much complex if you add dynamic keys, because dynamic keys could be anything, right? It could be a symbol, it could be a function, it could be some string. So for sure, it's going to create this object to a hash table behind the scenes. When you delete, second point is going to be when you delete a property from an object. Again, when you delete a property from an object, or if you think it is an array, so deleting a property between the array is going to be problematic. Then it is no more predictable. So it's ultimately going to use hash map to have a better structure there. And this is interesting one, like using non-integer key. So like if you have a dynamic key right now, here I do have a dynamic key of integers, but if you have a dynamic key like obj, and let me do this obj and maybe like hello there, a dynamic key as a string, a non-integer key as a string, or it could be as a function, could be null and defined. So ultimately it is going to be complex for array to handle, for hidden class to handle. So it's going to convert hash table behind the scenes. Next one is going to be for sure large number of properties. Okay, like we know, if you are having a very big object, it's going to ultimately convert it to a hash table behind the scenes. And let's talk about the array as well, like how the array is being converted behind the scenes. And if we talk about arrays, when arrays, when you have a sparse array, empty indices in between, like we just saw in an example, this array has so many indices as empty. It is going to convert to a hash map behind the scenes. The next one is going to be the non-integer key, or I would say non-sequential indices. Okay, so if you're wondering what exactly this is, let's take an example. If you do have an array, so not only you can use index number as an array key, you can also use string as an array key. It looks strange, but it is 100% possible in JavaScript to do so. In that case, it's going to create an array to a hash table behind the scenes. And maybe like the last thing I would say is going to be adding custom property to an array. For example, this is for this is going to be this. For example, you do have an array this, and you add array dot custom property hi. So if you add arbitrary properties like not numeric index, can also prompt the JavaScript engine to have a hash table behind the scenes rather using simple array there. And the last one for sure, big big array. So it's going to be created as a hash map behind the scenes. All right, let's take an example of this object and let's understand how this object is going to be stored into an hash table behind the scenes. Right. All right. So whenever your JavaScript is going to read this object, let's suppose it has thousands of properties here. So obviously it's going to take into consideration that it should use an hash table rather than storing them in an array because it's a very big object. Now, hash table is very simple. Hash table has two. First thing, that is hash function. Hash function. So hash function is just a formula by which hash table is going to get a key of the value you are storing into hash table. It's just a function, it's just a logic which going to convert, which going to create a key for you for the hash table. And after this, you're going to have the actual table. Key value for now. Okay, let's take an example. Suppose this is my first property which is going to be stored into an object, into an hash table. What's going to happen? If you are storing a key and a value, key, specifically key as an integer, is not going to do anything behind the scenes JavaScript engine. It may differ in other languages, but in JavaScript engine, it's going to use integer keys as same for hash table. It's going to be 1, the value is going to be 1. Very simple. If you are using symbol, then symbol also has a unique identifier behind the scene. Symbol in JavaScript is basically a unique value. So it's not going to convert it to anything and it's just going to store it. It's just going to store it in this hash table like this. Maybe symbol. And the value is going to be 55. It's going to start from the first for sure. For an example, I'm showing you from the simplest value I do have in this object. Now let's take an example of strings. This is the string value, let's assume. In the case of string, what's going to happen is going to perform some hash function behind the scenes. So behind the scenes, if we talk about string values, it does perform a hash function which is called more hash function. So it's a function, it's a functionality. We are not going to discuss about it in this video, but it has this implementation which is going to convert this key into the unique hash based string content. It could be like, let's take an example. If you have this, so it's going to be converted into some other string, maybe like A01. Let's say an example, it converting into another some hash value as a key, and it's going to store a value there. Now, there is very common thing happens in the hash table, overall hash data structure, that is there are collisions. There could be a case, let's suppose for this value could also get converted into the same key. OX could also have a same key if we are performing some business logic to convert this into a key, into a hash key. There could be a chance multiple values could have same key. Now what's gonna happen? Right now, this data structure, this hash table is pass mode data hash table. So it's going to perform an operation or an algorithm which is called open addressing. And let me just move it. Whoa. Okay. Hack it. Let me remove it. And let's try it here. Fast mod, which performs open. Cool. In the first place, it's just going to use fast mode as the first type of hash table when your object is being converted to an hash table behind the scenes. Open addressing is very simple. It's going to find out available space in the hash table like it does for this, but when it has another key which also corresponds to a same key value in hash table after converting it using a hash function, then it's going to create a bucket. Now it's going to be a bucket rather than the actual value. Bucket 01. It could have a unique identifier. I'm just naming it as bucket 1. Now this bucket 1 is going to use linked lists behind the scene to store these values. So first value is going to be in our case is 1. It is going to be 1, right? Yeah, it's going to be 1. Then after that, it's going to have a value which we added to next time, that is 12. Now it is being treated as bucket. Now when you're going to read it, so again, when you're going to read this value AX or OX, then it's going to have this key, same key for both X, Y, and OX. Then after coming to this key and finding it's a bucket, then it's going to compare the actual key with these values. So these values also going to have the keys as well, like X, Y, OX. And whatever keys it's going to find, it's going to return you that value. Wow. It's going to return that value. This is called bucketing. Your hash table use bucketing behind the scenes when it has collisions, when one or more values has the same corresponding keys in your hash table. All right. So there would be a case when you're going to have lot of values in your hash table, and there are going to be lot of deletions. I would say lot of deletions, or maybe it is expanding to double of size, maybe 10,000s of records. Now in that case, what's gonna happen? It's going to convert this hash table to a different mode that is going to be called as dictionary mode. So dictionary mode is basically it's very similar, but behind the scenes, the algorithm it does use to store the values in this hash table is going to be different. However, there are a few others takeaway. So each object has its own hash table. It is nothing like it's the one big hash table behind the scenes in the memory which stores everything. Each object has its own hash table. And if your object is of multiple objects, sharing same properties. Let's take an example. You do have an object obj1 which has a1, and let's add another property, maybe b2. Const obj2 a this, b this, and let's remove this. So in this case, like we know, it's going to use array behind the scenes for this simple object, but they're both going to share a single hidden class. Because hidden class is nothing, it's a structure, it's a shape of the object, right? And both have the same properties. So optimize the memory usage. Your JavaScript engine does check if any other object has the same properties, and they are going to be allowed to use a same hidden class rather creating two separate hidden class in the memory. Hope you like this video. If you like, please leave a thumbs up, subscribe, and share it to your friends. If you want to learn anything else from the topics on this video or some outside topic you want me to make a video for, I can do it. Just leave a comment. I will make a video on it for sure. Thank you so much and have a